Okay, so here are some supplemental problems for section 8.2 Pythagorean theorem. These are right out of the book. Number 3, they're asking you to find the missing side length, and it's a right triangle, so we can use the Pythagorean theorem. Our only real concern here is that we have to know that C, and then either one of these we can call A or B. Okay, so I'm going to call 4A and XB. So now it's going to be A squared plus B squared equals C squared. Excuse me. So 4 squared plus X squared equals 16 squared. 4 squared is 16. X squared 256. Subtract 16, x squared is 240. And now the real work, and that's why I chose this one, is that I have to take the square root of both sides. Breaking down 240, it's 24 and 10. 24 is, I don't know, 6 and 4. 6 is 2 and 3. 4 is 2 and 2. And then 10 is 2 and 5. And now again, I want to ignore all of the non-prime factors. So now we look for our pairs. And I'll do this in a different color, make it stand out a little better. I've got a pair of 2's. Okay. I've got another pair of 2's, which means I have 1, 2, a second 2, and then left over, unfortunately, is a 3 and a 5. So they're stuck inside. So this ends up being for us then 4 root 15 for that missing side. All right, next example is the use of the Pythagorean triples. Okay, and remember, those are the numbers that make special right triangles in the sense that they make all the sides be perfect, no weird radicals or decimals. So what we have to figure out first is what are the smallest numbers that both, or biggest numbers that both those guys are divisible by. In that case, it's 7. This gives me 3. This gives me 5. And they have to go through and say, okay, well, which one of our triples does it look like it matches up with? And we have 3, 4, 5 is a set of triples. 5, 12, 13. 7, 24, 25. 8, 15, 17. And 9, 40, 41. Any one of these or a multiple of it is a triple. And in this case, hopefully you'd catch pretty quickly. Oh, 3, 3, 5, 5. This must be then a 3, 4, 5. The problem is this isn't 3, 4, and 5 for the side lengths. It's 21, 35, and this. Well, to go from 21 to 3, I'd divide by 7. So I'll go back, multiplying by 7. X is 28. Oops, sorry, I ran out of space there. X is 28. Okay, so that's it. So it is a bit of a trick. You have to memorize all 5 of these guys to use them properly. But yeah, it's just a way to make some of this work that might seem more complicated a little easier. Okay, let's see. Last type of problem. Okay, last type of problem that I want to throw on here is the converse of the Pythagorean theorem. And that basically is just a way for us to check and see, do I have a right triangle, an acute triangle, or an obtuse triangle? Now, if a squared plus b squared equals c squared, I have a right triangle. Okay. If a squared plus b squared is less than c squared. What that means is, let's say these guys stayed the same size, but c got bigger. Well, here it is as a right triangle. If I make this guy bigger, but keep those the same, it's going to open that angle up. So this would be obtuse. And if a squared plus b squared is greater than c squared, that means I made c smaller. That means then this is acute. Okay. So that's what I'm looking to see. I'm going to check a squared plus b squared against c squared and see if I get equal to, less than, or greater than. So I have to, of course, identify that c is the longest side. That's the real trick. And c is in this 24 in this case. So now what I'm just checking out is, how does 15 squared plus 20 squared, how does that compare to 24 squared? 15 squared is 225. 20 squared is 400. 24 squared is, I think, 576. Yeah, 576. So when I go to compare these, I get 625 versus 576. Oh, a squared plus b squared is bigger than c squared, meaning what happened is it's not a right triangle. C is collapsed down to make it smaller, so this guy is an acute triangle. Okay. That's not all the section, of course, but it's just kind of the three basic problem types we see in this section. There's some word problems as well, but yeah, that's just the kind of general basic type. So if you have any questions, if anything doesn't make sense, if you feel like I skipped something or you had questions from class, come on in and I'll come help you out.